Namaskar Bondhugan. Welcome to my YouTube channel Sahil Educations, and I'm Sahil. Today we'll be learning about some tricks to draw the monosaccharides Fischer projection. So let's start. We'll first start with G, E, T, R, A, X, L, and then we'll write all ultros gladly make gum in giant tanks. This is the basic thing that you have to write in your copy. Remember that G gets divided into two forms or two parts, then coming to E and T. Then E is again being divided into two parts, T is again being divided into two parts, and then for R it is being divided into all and ultros. A gladly make, X gum in, L giant and tanks. Okay, this is the basic tree in which G stands for glyceraldehyde, E stands for erythrose, T stands for triose. In the same way, R for ribose, arabinose, xylose, Galactose. Then all for allose, ultros, gladly glucose, mannose, gulose, iodose, galactose and talose. These are the forms of monosaccharides. Remember, if we see the number of carbon atoms in glyceraldehyde, it is 3. In case of erythrose and triose, it is 4. In case of ribose, arabinose, xylose and Galactose, it is 5. In case of allose, ultros, glucose, mannose, gulose, iodose, galactose and talose, the number of carbon atoms are 6. So in the same way, you can see that at every step, number of carbon atom is increasing by 1. So it can be said here, if the structure of glyceraldehyde is like this, it is a 3-carbon compound and it can have two forms, two enantiomer. This one is the D enantiomer or D form of glyceraldehyde, and if we see the structure like this one is the L form of glyceraldehyde. If you have not seen the isomer part yet, go and watch the isomer part first and then come back to this section. So let's take the D form in every step. Let's take the D form in every step and we'll be drawing the erythrose and triose first, so that you can understand the way in which the carbon atoms are being added and its appendages like hydroxyl group and hydrogen are being added. Where the hydroxyl group will attach, in the right side or in the left side, or the hydrogen which will attach in the left or right. Just see, in case of erythrose, we know this one is the 3-carbon compound, it's a 4-carbon compound. That means one more chiral carbon will be added here. 2 chiral carbons, here CHO and here CH2OH is present. In case of glyceraldehyde, the form was like this. H is in the left side in case of glyceraldehyde, and whereas this erythrose E is belonging to the left side of G, that is why in this chiral carbon H will also come to the left and the rest will contain OH. In case of triose, it will also be like this. Here CHO, CH2OH. In case of glyceraldehyde, the H was in the left, and where the T is remaining or is at the right of G, that is why in this chiral carbon the H will come to the right. So this is now triose. What will happen in case of ribose now? So if we see ribose here, 3 chiral carbons will be present. This H is for glyceraldehyde, then coming to E which is at the left of G, then this one is the H for erythrose, and this R is belonging to the left of E, so in the left the H will present and the rest OH. In case of arabinose, what will happen? See and try to figure it out in your own mind, that for G, H is at left, for E which is left of G, so the H will again come at left, and this A is at the right of E, so the H will come at the right now and the rest will be OH. This is how we can draw our own structure, own Fischer projection of these monosaccharides. Okay, let's take examples of these 6 carbon compounds. See, this is the tree here, the tree which we have heard about in the earlier part. So let's draw allose. Let's draw allose. It must contain 6 carbon. So starting from G, this H will at left. E is in the left of G, so again H will come at left. R is again at the left of E, so H will come at left. And this all allose, this comes in the left of R, so again the H will come at left. Rest of the things, that means OH, all the OH are present in the right. This is allose for you. Let's make now mannose. See, G, left hand side, E is in the left, no, okay, E is in the left, so H will come at left. Then again coming to A which is at the right of E, so in next part the H will come at right hand side. And then this M, this mannose is at the right of A, so again the H will come at the right hand side and the rest OH. CHO and CH2OH. See, this is how we can make mannose here. Let's suppose about galactose. See, galactose, G in the left hand side, H, T is in the right of G, so H will come at right. Then coming to L which is at the right of T, so H will come at right. And this G, galactose, is in the left of L, so the H will come at the left hand side. Rest, fill these OH. This is our galactose. Let's suppose now make talose. For G, H is at left. For T, H is at right because T is here in the right side of G. Then coming to L which is again at the right side of T. Then this H will come at right. And this talose is again at the right of L. So this H will come at right. And the rest of the things will be OH. This is talose. This is how we can make our monosaccharides Fischer projections. So I hope you have understood the concept. You just have to remember this tree and you will be able to prepare or draw your Fischer projections of these monosaccharides. Thank you. See you in the next video.